Hello everyone, my name is Dr. Mohit Sharma and this is our second video on reinforcement learning. So in this video we will cover the Q learning algorithm and we will see how it is implemented. So let's go ahead. So let us start with the Q learning. Okay. The Q learning is a one such algorithm for reinforcement learning which is an off policy algorithm. Off policy algorithm means that the agent learns from its past experiences, right? So there are other kinds of algorithms are available as well, which are on policy in which agent does not store its past experience. Okay, so those are called on policy, like proximal policy optimization, SARSA, and other algorithms. So this is basically the off policy algorithm in which the agent learns from its past experience, or we should say like it is a past stored experience, right? Okay. So there are several features in the Q-learning that we need to first understand, and then we will implement the basic Q-learning algorithm for a specific use case. Okay. Okay. So in Q-learning, what is Q actually? Q refers the quality of an action. Okay. Q refers to the quality of an action that an agent takes. Right. So let's say in the previous video also we have discussed it, like we have a grade, okay, and the agent is present here and he wants to go to this goal, and but there are lots of barriers, okay. So the agent needs to decide which path he should take, okay, which is the optimal path so that it can easily go to its goal, okay. So this Q refers to the quality of an action. Like if let's say agent reaches to this point, so at this point, what action the agent needs to take so that it can easily go to its goal, right? So we can say that okay, since logically it seems that the agent needs to take a action which is on the right. Okay. So the quality of that action determines the value of Q of the state. Okay. So there are other parameters as well, like learning rate, how fast the agent is learning, okay, which is determined by alpha. So it determines how fast the agent learns from its environment, right? So it is basically the learning rate that we usually use in our machine learning, okay. And then we have the reward. Reward we denote by R, right? So it is what the agent gets when it moves from one state to another, okay. So basically it is what the agent gets, okay, from moving one state to another, right? Okay. So we have seen that okay, if the agent is present in one state and the action determines what is the quality of that state. Okay, alpha determines the learning rate, how fast it is learning, right? Reward determines what the agent gets in return. Okay, and then there is another thing which is called discount factor, which is denoted by gamma. So let's say you are in this position, in position A. Let us say this is the position A, this is the position B, right? So now you need to take an action in this position A. Let's say, you can say that okay, the goal is on the right hand side, so we should go towards right hand side, right? But sometimes it can happen that you need to take different action like this one, which is not towards right, but it is uh, towards bottom. Okay, so the discount factor determines how importance you have to give to your nearest reward or your future rewards, right? It can also happen that your optimal path goes from here instead of going from here, which seems logical, but it may not be the uh, optimum path for this agent to reach to its goal. Okay, so discount factor balances between these nearest or farthest rewards. Like it can happen that agent is more greedy towards the near rewards that it will get from one state to another. Okay, but being more greedy will not be the optimum case. Like it can happen that the agent may not get the immediate reward, but in future it will attain more rewards. Okay, so we will see this once we will go through an use case. Okay, so these are the basic parameters for the q learning, and the update function, like how the agent is learning, that update rule is determined by this. So this is a q value for a new state, right? Given the state s at time t and action at time t. Okay, this is equal to 1 minus alpha, which is learning rate, q value of the present state and present action, right? Plus alpha times the reward that it will get from passing from one state to another state. Okay, plus gamma, which is the discount factor, times max value of the action, which the value of action which can give you the maximum value of q for the future state, q as t plus 1 comma at. Okay, so this is the update formula for the q learning algorithm. Okay, let me explain it again. So the q value of the new state, okay, it is the quality of that of the action A given a state S at time t. It is equal to 1 minus alpha, the quality of the state S given action AT, plus alpha times reward that you will get after taking some action, plus gamma times value of A which will give you the maximum value of q for the next state, right? So this is the formula, or this is the update rule for the q learning. Okay. So now let us go to an example, a simple example that we will just cover. Okay. Okay. So let us say that we have three states A, B, and C, right? So C is the goal. This is our goal, and A is our starting point, initial point. Okay. So we have to first, I mean, from A to C, how we can go? We can first go to B and then we will go to C. Okay. But in the environment, it is designed in such a way that when you go from A to B, you will get zero reward. Reward is zero. Okay. When you go from B to C, you will get reward plus 10. Okay. Or when you are in A, whatever action you will take, whether you will take left action or right action, your reward will be zero. Okay. So you will only get the reward when you will go from B to C, or you can say when you will take the right action at B, then only you will get reward. Otherwise, you will not get any reward. Okay. So this is our basic example. Okay. Now we have to see how we can use this update rule in this use case. Okay. But we also need to define some parameters like the learning rate that we need to define. Let us say the learning rate is something 0.5, and let us say that our gamma is 0.9. Usually gamma is between 0 and 1. So if it is equal to 1, we will give the equal weightage to all of the future rewards. Okay. And if it is less than 1, we will give more weightage to the nearest rewards. Okay. So these parameters we are defining. Okay. You can take some other parametric values as well. Okay. So in the first step, what will happen? Like you are in position A, okay, and then you can take any step that you want. So let us draw a Q table first. Okay. So let us denote all our states and actions in this Q table. So this is the column for state, this is the column for action, and this is the column for Q value. Okay. So we have state A, B, and C. Okay. In state A, we can take two actions, towards right, towards left. Okay. And initially there is no Q value, so it is 0. Similarly for B, we can take any action towards right or towards left, right? So Q value is 0 for this also. And in C, it is not dependent on any action, because if we reach at C, then we will get the reward. Okay, the episode will end at that point. So let us keep it blank. Okay, and the Q value is also 0 for this. So initially the Q value for all the states, whatever action we define initially, Q value is 0. Okay. So now let us suppose we are going from A to B. Okay, this is our first episode. First episode means the agent will start learning from this point. So this is our first episode, and in this first episode the first step is agent is at A, now it is going to B. Okay, but we have seen that from A to B we will not get any reward, so reward is equal to 0. Okay, and now what we need in this update rule, we need, see, our reward is 0, we have alpha, right, we have gamma. Okay, now what we need, we have QSTAT at present, which is also 0. So what is remaining is max AQST plus 1. This is basically the Q value in state B. Okay, the maximum value of Q in state B for a particular action. Okay, so we need Q, alpha and gamma, and for this max QST plus 1A, this is also 0 because it is the next best action. Next best action, okay, in B. So in B you can have two actions, right, left hand side and right hand side. So it is a max of both of the actions, I mean both of the Q values for left or for right, 0 comma 0, so it is 0. So your Q, the max AQST plus 1 for B is 0. Okay, so now what is the Q value for this state A? Q value for this state A when we take a right action, okay, it is equal to 1 minus alpha, 1 minus 0.5. Okay, and the reward is 0, we will not get any reward, so it is 0, and then alpha times reward 0 plus gamma is 0.9 times this max is equal to 0, so it is equal to 0. Now if we compute it, so it's 0 plus 0, it's 0. So Q values will not update when we go from A to B. Okay, now in the next step, when we go from B to C, okay, so how much reward we will get? We will get reward plus 10. Reward is equal to plus 10. Okay, and what is the next best Q in C? It is also equal to 0. Okay, because in this table the Q value for C is equal to 0. Okay, so the Q value for B when it takes a right action, it is equal to 1 minus alpha, okay, times reward. Reward is 0, okay, plus 0.5 times 10, which is equal to 5. This is, sorry, this is the Q value. Sorry, this is a Q value. Yeah, it is given here. Okay, reward is not 0, reward is 10, but Q value is 0. Okay, so Q value for state B when it takes a right action, it is equal to 5. Okay, so now we have to update our Q table. Okay, so it is state action Q value. States are A, B, C. Okay, This is two actions, right, left, and blank. So Q value is not updated for A. Okay. For B, it is updated when it will take a right action. So it is equal to 5, right? And when it takes a left action, it will be 0. For C, it will still be 0. Okay. So we have updated our Q table. Okay. Okay. Now let us go to second episode, because in this episode we have reached to C. So when once it reaches to C, the episode will end. Now we have to again start from A in the next episode. So from the first step, we will see that the agent, let's say it is going from A to B. Okay, A to B, reward is 0. Okay, so what is the next best queue in B? So in B, it is the max of 5 and 0. Okay, max of 5 and 0, which is nothing but 5. Okay, so q value for the state A when it takes a right action, it is equal to 1 minus alpha times q value of state A is 0. Okay, plus alpha times reward is 0 plus zero point 0.9 times the max value of q in state B in the future state, which is equal to 5. Okay, so it is 0 plus it is equal to something 2.25. Okay, which is 2.25, right? Okay, so q value from state A when it takes an action towards right, the q value is 2.25, right? Now we need to go from B to C in the second episode. B to C. Okay, so what is the current q value? Current q value of B when it takes a right action, it is equal to 5, right? This one. Okay, it is equal to 5, and the reward that it will get from B to C, it is equal to plus 10. So now the q value for B when it takes a right action, it will be 1 minus alpha zero point 0.5 times the q value for the current state, which is equal to 5, plus alpha times the reward. Okay, so it is equal to zero point 0.5 times 5 plus 50 times 0.1, so it is 5. So it is equal to, this is 0.25 plus 5, which is equal to, no sorry, this is 2.5. This is 2.5 plus 5 is equal to 7.5. Okay, so the q value is updated, right? So now we have to, since the episode is ended, so now we have to again write the q table. So these are our state, these are our action, these are our q values. Okay, so we have three states A, B, and C. We have actions right, left, right, left, and blank. So what is the Q value for A? It is 2.25 when it takes a right action. Okay, 2.25. For left action it is 0, and for B when it takes a right action it is 7.5. When it takes a left action it is still 0, and for C it is still 0. So we can see that our Q values are now updating. Okay, so let us go to third episode now. Okay, so in the third episode let us again start with point A. So the agent will go from A to B. Okay, from A to B reward is 0. Okay, and next best Q for B or in B, which is equal to max of this 7.5 and 0. Okay, 7.5 and 0, which is nothing but 7.5, right? So the Q value for the state A when it takes a right action, it is equal to 1 minus alpha, right? The Q value for state A, which is 2.25. Okay, 2.25 plus alpha times reward is 0 plus gamma times 7.5. Okay, so this is equal to zero point 0.5 multiplied by 2.25 plus zero point 0.5 times 0.9 multiplied by 7.5. So this is 1.125. Okay, and this is around 3.375. Now if you sum up both, it is 4.5. Okay, so the Q value you can see it is updated now, right? So now we have to go from B to C. In B to C, what is the current value of Q in B? So Q value in B when it goes towards right, it is equal to this 7.5. Okay, 7.5. Now the reward that you will get from B to C, it is equal to 10, right? So what is the Q value now in state B when you take a right action? It will be updated to 1 minus alpha, right? Q value in state B plus alpha times reward. Okay, so this will be approximately 8.75. Okay, so now you can see that the Q values for all of the states are updated now. State, action, Q value, state A, B, C, right, right, left, blank. So Q value for state A is 4.5 when it takes a right action. For left hand side it is 0, and the Q value for state B when it takes a right action it is 8.75. For left hand side it is 0, and for C it is also 0. Okay, so now go to fourth episode, right? So let us again start from state A in the first step, A to B. So what is the next best action or next best Q in B? It is 8.75, right? So max of 8.75 comma 0, which is 8.75. Okay. And what is the q value for a when it takes a right action now? It is 1 minus alpha. Okay. Q value in state A, which is 4.5, plus alpha times reward is 0, discount factor multiplied by 8.75. So this is zero point 0.5 multiplied by 4.5 plus this is 4.5 multiplied by 8.75. So it is 2.25 plus 3.9375, which is approximately equal to 6.1875. Okay. Similarly, from B to C, right, the Q value is when it takes a right action at P, it is equal to 1 minus alpha. Okay. The Q value in B, which is 8.75, 8.75 plus alpha times the reward that it will get, 10. So it is something 9.375. Okay. So what is our Q table now? State, action, Q value. So states are A, B, and C. Actions are the right, left, and blank. Okay. So the Q value for state A is 6.187. So 6.19 approximately. For left action it is 0. For right action it is 9.38. For left action it is 0. And for C is also 0. Okay. So what is happening actually? You can see that your Q values for these particular actions are improving with time. Okay. With each episode. So the Q value in state B, it is currently 9.38, but when you will do for more episodes, it will become nearly equal to 10, which is our maximum reward. Okay. Or which is our true reward. So your Q value approaches to your true reward that you have. Okay. So this is the way in which the agent will learn based on the Q values that which action it needs to take at which state. So the more the Q values are, okay, the more the probability that agent will take this action, okay, during the exploitation phase. Once it will explore in first few episodes, but after certain episodes, the Q value gets saturated, okay, with time, and the agent will choose more and more these actions, okay, in these states. So this will determine what path the agent will take, okay, after let's say 10 or 20 epochs. It will be very clear. Okay. So this is how the agent will learn to take up certain actions at particular states. Okay. So I hope you liked this video and you understood about the basics of the Q learning. So if you like this video, please share with your friends and please don't forget to subscribe. Thank you.